This video will introduce you to the Freedom family of test systems. The FTS 940 is a hybrid test system that's a member of this family. This system provides you with flexible hardware and an easy-to-use software environment to give you efficient programming and troubleshooting that you need to meet your demanding manufacturing and depot support requirements. Every member of the Freedom family of test systems share a common set of system-level tools. Everything is based on XML, and all of the software was developed using a modular open systems architecture or MOSA approach. System-level programming tools, including Live, help your programmers develop their TPSs efficiently and quickly and help your operators troubleshoot failures and anomalies on the test systems. System self-test is provided with each system. We provide you with an ITA and all of the software to guarantee that your system is up and running when you need it and that you can diagnose the system when there's problems. Tools like Buzz and Pin Finder and Single Pin Buzz help your engineers and your operators debug system level or UUT type failures. We're now going to give a demonstration and discuss a recently completed effort for migrating 32 RIU box level test programs from a Teradyne L series machine onto an FTS 940. For this effort, our customer had some stringent SOW requirements, including at least a 50% reduction in TPS runtime and reuse of all the legacy equipment and code. They required us to develop a custom modular user interface that you see here. It's populated completely by XML configuration files. The XML describes not only the project that we're in, but also the system configuration and all of the system signaling paths. That allows a complete modular, scalable approach to TPS development. We had to enable all of the operator features through XML for the different types of test environments, end-to-end test, functional test, environmental test, very similar to what you do in space programs today. In order to start the program, you just tell it to start after you've populated the menus. You go in and you tell it to test UUTs. You're going to be offered the option to select whether you want to use simulation mode or run on actual hardware mode. So in the simulation mode, you can run this at any desktop without the requirement for hardware. That includes development using LabVIEW, CVI, .NET, or just about any other commercially available application. You'll see to the left in the operator console a log file that's being generated. The log file is actually being stored in text and in comma-separated value format at this time. You'll see me opening them now. This particular customer wanted the log files to be stored very much like the traditional L-series log files, just to make their procedures and everything else that they have internally right now stay relatively unchanged. So we met all of those requirements and gave them everything that they need. We can store the log files in XML, in comma-separated values, in database format, or just about any format that you want that's available on any modern computer. You'll see that the test program keeps running while we interrogate the log files, and you'll notice that the notepad continues to ask us if we want to update the log files as we open them. That's because Notepad and the text file are being populated with the new data as the program is running. This lets you go in and look through the history of what happened during this particular TPS execution. You'll see on the left window the 1553 is being tested, and it'll look a lot like what you're using today in space systems. That's because the OSC RIU boxes are very similar to yours, and they have the same functionality. Lockheed's actually teamed with OSC on a few of these efforts. We will come to a breakpoint, and I will demonstrate some of the troubleshooting tools that we've developed to allow you to have access to the instrumentation and the matrix in very similar fashion that you could in the L series world. We're at a breakpoint right now, And you'll see the log file, the end of the log file matches what's up in the operator interface right now because it's what's stored at this point in time. When you look at the actual test stand code, it looks very much like traditional L-series code. Now we're going to open up our live interface. This will show you what's connected, what pins are there, and it has some advanced features that you haven't seen in the Teradyne world. You'll notice that for this particular one, it now tells us that this particular point is connected analog, and it's connected to STJ connections. It goes through the Virginia panel interface, and it's also connected up to the universal timer counter. There's no jumpers set. The actual pin at the box is indicated as well, and this happens through the use of the XML, and it shows you every connection that's made on the matrix or made through digital at any point in time. The live interface allows you access to every one of the instruments. You can see the oscilloscope here. For the oscilloscope, we have to initialize the scope. We'll do that just by clicking on the init button. And then we can go over and we can select what pins we want to connect to the scope. This lists all of the pin bars as well as all of the UUT connections. So we can go in and we can select the same pin that we have indicated over here as connected analog, and we can start sampling the pin. And we can connect that to any one of the scope channels, can set a breakpoint at any point in the test stand code and connect up any pin that we like. This is probably a good point to discuss one of the features that were required from the customer. For every change that we make to the test system, we have to persist the exact state of the test system at that point in time. This was important to them in case there was some sort of a catastrophic failure or an anomaly that occurred that may have damaged a piece of spacecraft hardware. So we store every single relay, every single system change, every digital, every analog change into XML databases that are used to recover the state of the system in the event that something like that occurs. It's also used to allow us the ability to connect up and to use the matrix features and the instrument interface and the live features that we've been demonstrating here as well. As we resume testing, you'll notice that the scope starts showing the waveforms again. The operator console again starts showing the activity that's going on as we're testing this particular payload box. And it continues clicking through the test stand code as we go until we come to breakpoints that we have set. I'm going to show you how we can set it, just simply break live, go into the test stand code, and set breakpoints wherever we like within the code. So we go to case statement 8 here, we set a breakpoint, we tell it to resume testing, and again the test system starts going. And it looks like we've already hit that breakpoint, so just by chance we picked a bad spot. Let's pick a better one. We'll go in and we'll set it inside this for loop with the case statement to case 9 instead. That way we'll get a little bit of time where it's running. Tell it to resume testing. You see the waveforms start coming out on the scope again, and the operator console would be displaying the actual activity that's going on and logging it. And it'll hit the breakpoint in a couple of seconds, and then we could continue troubleshooting much the way that we have with the live interface up to this point in time. It's really handy to be able to just stop at any point and be able to do that. It greatly expedites your programmer's ability to close a TPS and to troubleshoot anomalies when they occur. Other features that we have built in include methods to save and print the data from the scope. If we click on the print screen, it opens up the standard Windows print interface, and you could just print the waveform out. You'll notice that the signal names and the dates were automatically populated when we set up the scope. You can also save it to a file name and select the format, PNG, JPEG, whatever, standard with any text scope. Well, we could continue running the program, but it would take hours, and I think we've demonstrated many of the advanced features that you would need. The one that I just clicked is a save feature that saved the signal setups into a text file, and I'll show you the text file here. We can use this text file to go in and cut and paste the line that shows what was set up in that particular point. And we can use that to populate our test stand without actually writing the code or figuring it out. So you just select this line, copy it, and you paste it into test stand, and it will fully enable test stand to set the instrument up exactly how it was set up when we just executed live. We'll terminate the sequence now. I appreciate you taking the time to listen to our facts and features about our test system. If you need any additional information, please call us or check out the other videos that we've posted online. Thank you.